A new luxury car is available to win. Stop by and have a try at the Lucky Wheel. Upgrade your wardrobe and finally become the person you believe yourself to be. Stop by the casino store and treat yourself.
Just a moment. Goodbye.
Enjoy. Don't be reckless.
I wanted to get something for Bart for watching the animals, but no siree. Oh, I'll just make her some of that soup she likes.
See you again soon. I'll be right there. Come back soon.
this, huh? The product's in the back of the truck and ready to move. Get it to the buyer, and you're done. That's a success.
dick! Bring it, motherfucker! Oh, shit, man! Fucking cocksucker, punk! You're dead!
Did you forget about your patron Simeon? Let me know if I can be of service.
You will learn about fractions and how they apply to the work you perform. Whether you are a line worker, electrician, mechanic, or a plant operator, this instruction gives you a basic understanding of fractions and builds your confidence for using fractions on the job. Applying math on the job is a skill that is developed over time through practice and experience. So be patient. Give yourself time to digest this critical information. The word fraction comes from the Latin word factio, which means to break or is part of. When a whole number or some other type of unit is divided into parts, pieces, or sections, we call those parts fractions. Fractions are a part of a whole. You will use or already use fractions for counting, measuring, and calculating a variety of tasks that you perform on the job. Here, you see a rectangle representing the length of a whole drawing, divided in half, then divided into quarters, then eighths, then sixteenths, and finally 30-seconds. Fractions are important when measuring the length of objects. For example, when you are staking out the perimeter of a foundation for a cement slab, fractions often come into play when measuring lengths, widths, and heights. So, you can see that fractions are a part of a whole unit, whatever that unit may be. You will use fractions when you are working on tasks that require adding, subtracting, multiplying, and dividing values that are parts of a single unit. Whatever that unit may be, fractions are used for a variety of measurements, including determining length, weight, volume, and area. You will need to have a good understanding of fractions as you apply them to tasks performed on the job. For example, you may need to use fractions when measuring pipes that are used in the cooling system, weights of chemicals or other materials, oil drums for draining transformers, or to calculate the diameter of pipes and poles. Using a standard tape measure, let's explore how fractions break down into smaller units. Here is a simple illustration of the concept of a fraction. See the inch markings on the ruler? 1 inch, 2 inches, and 3 inches, etc. The ruler is marked out in inches. The various ticks you see on the ruler break out each inch into equal parts of halves, quarters, eighths, and sixteenths. Let's look at the 1 inch marking. The 1 inch is broken down into half with the half-inch marking. Here, each inch is divided into halves. The ruler shows the inch divided into quarters. Here, the inch is broken down into eighths. And here again, broken down into sixteenths. Whether you are at home, at work, or just out and about, fractions are the building blocks for developing your math proficiency level in preparation for work you will perform in the electric utility industry and power industries. You can now proceed to the fractions basics section to learn more about the terminology and rudiments of fractions. Common fractions are usually referred to as just fractions. You will use fractions in some form or another in the work you do in the electric and power industry. As you have already learned, fraction is a part of some unit. The bottom number is the denominator, indicating it is the whole of some unit, whatever that unit may be. For example, a 2 by 6 by 12 framing board before it is sawed apart. The top number is the numerator. It indicates how many parts of the whole remain, or how many parts have been used. Here is a tip to help you remember which number is which. Think the letter D for down. To remind you, the denominator is the number on the bottom beneath the horizontal line. So the denominator is the number beneath the line, and the numerator is above the line. In this example, 3/4 means you are working with 3 of the 4 parts. 1 part has been used, and 3 parts remain. Fractions can be proper or improper. A proper fraction is a fraction whose numerator is less than its denominator, as seen here, 3/4. An improper fraction is one where the numerator is the same as or greater than the denominator. For example, 9/8. The number 9 is larger than the number 8. Or, for example, 17/16. The number 17 is larger than the number 16. A fraction where the numerator is the same as the denominator, as seen here with 4/4, is also an improper fraction. 4/4 is also equal to 1, and therefore a whole number as well. A mixed number is a number that consists of a whole number and a fraction, such as 3 1/2, 5 2/3, or 4 7/8. We will talk more about these types of fractions in a later lesson. Divisible by means there is some common number that divides both the numerator and the denominator perfectly without remainders, or numbers left over. Anytime a fraction is made up of large numbers, 4 or higher, that gives you a clue that they might be able to be reduced by dividing the numerator and the denominator by a common divisible. The key here is that both the numerator and the denominator are divisible by the same number. This is referred to as reducing. As in our 6/8 example, we can reduce both the numerator and the denominator because the numbers 6 and 8 can be divided by the number 2. 6 divided by 2 is 3. 8 divided by 2 is 4. Make sense? Here's how it works. To reduce the fraction 6/8, we use the divisor of 2. 6 divided by 2 is 3. Dividing 6 by 2 cancels the 6 and replaces it with 3. 8 divided by 2 is 4. Dividing 8 by 2 cancels the 8 and replaces it with 4. Therefore, reducing the fraction 6/8 with a divisible of 2 results in 3/4. In addition to the number 2, other numbers that you will use for reducing fractions are 3, 5, 7, and 11. Here are some general rules that will help you find numbers for reducing fractions. Only even numbers are divisible by 2. All numbers that end in 0, 2, 4, 6, and 8 are even numbers. If the sum of the digits is divisible by 3, the number is divisible by 3. Numbers ending with 0 and 5 are divisible by 5. There's no easy rule for using the number 7, except for maybe memorizing the multiplication table. If a number is less than 100 and both digits are the same, the number is divisible by 11. For example, 11, 22, 33, 44, and 55. The lowest common denominator is the smallest number that is a multiple of all of the denominators in a given math problem. Let's take an example to demonstrate how to find the LCD, or the lowest common denominator, for a group of fractions. Here, we will use 3/5, 5/9, and 7/10. For step 1, simply type in the denominators for each fraction. Use the Tab key to move from cell to cell. For step 2, start to reduce each denominator. Most often, 2, 3, 5, 7, 11, and 13 will be the numbers needed. In many cases, you will know just by looking at the numbers. Here, you might tell that the number 5 is not divisible by 2, so carry the 5 down to the step 2 row. 9 is not divisible by 2, so carry the 9 to the next row. Finally, 10 divided by 2 is 5, so type 5 in that table cell. For step 3, 5 into 5 equals 1. Carry the 9 to the next row. And 5 into 5 equals 1. I could have used the number 3 first to divide into 9, but I'll get to it in the next step. Complete steps 4 and 5 the same way as in step 3. When I completed all the rows and end up with a row of ones, as seen on the step 5 row, the operation is complete. However, if the row for step 5 had any number larger than 1, that number would also be used in the multiplication for the LCD. There is only one step left, and that is to calculate the LCD. Multiply the bolded red numbers to get the LCD for the fractions 3/5, 5/9, and 7/10. 2 times 5 times 3 times 3 equals 90. So, the LCD is 90. Simple enough. Remember, if the row for step 5 has a number that is larger than 1, include that number in the multiplication for the LCD. What is the answer to 4 minus 2 and 5/7? When you are faced with adding, subtracting, multiplying, or dividing fractions and whole numbers, simply remember that a 1 can be changed to any combination, such as 7/7, 2/2, or 4/4. In other words, borrow a 1 from the whole number to give you a fraction that represents a whole. Remember from an earlier What is the answer to 4 minus 2 and 5/7? When you are faced with adding, subtracting, multiplying, or dividing fractions and whole numbers, simply remember that a 1 can be changed to any combination, such as 7/7, 2/2, or 4/4. In other words, borrow a 1 from the whole number to give you a fraction that represents a whole. Remember from an earlier lesson when it was stated that 4/4 equals 1? It can be reversed as 1 equals 1 over 1. So, in order to find the answer to this fraction problem, we need to place a number in the answer box next to the number 4. Let's work it out together to demonstrate how borrowing works. Take one whole number from the whole number 4. 4 minus 1 equals 3. Use the 1 to create your fraction 7/7. We use 7 because that number is the lowest common denominator. We took 1 from the number 4 to create the fraction 7/7. Now you can subtract both the whole numbers and the fractions. Here is the problem completely worked out, showing that we borrowed from the whole number 4 to create 7/7 needed to perform the subtraction. What is the answer to 4 minus 2 and 5/7? When you are faced with adding, subtracting, multiplying, or dividing fractions and whole numbers, simply remember that a 1 can be changed to any combination, such as 7/7, 2/2, or 4/4. In other words, borrow a 1 from the whole number to give you a fraction that represents a whole. What is the answer to 4 minus 2? In order to add or subtract fractions, each fraction must have the same denominator. The common denominator is 8. Adding the 5 and 7 equals 12, making the fraction 12/8. However, you would also reduce the 12/8 by using the divisor of 4. 4 into 12 is 3, 4 into 8 is 2, giving you an improper fraction of 3/2. We would then change the improper fraction to a mixed number by dividing 3 by 2. That in turn would result in a mixed number of 1.5. So, as you can see, many of the fraction rudiments are applied here and provide you with insight as to the importance of the basic fundamentals of fractions that are used by the electric power industry work groups and jobs. Subtracting fractions with the same denominator In order to add or subtract fractions, each fraction must have the same denominator. The common denominator is 8. Adding the 5 and 7 equals 12, making the fraction In order to add or subtract fractions,